we're going to go ahead and actually get the position. We're going to actually solve this whole packet, the homework. So here we go. We want to get the velocity graph from the position graphs. To do that, we're going to go ahead and calculate slope. So I have this graph here, 4, 4, and 0, 0. And so to get the slope, V naught is going to be 4 minus 0 over 4 minus 0. That's the rise over the 1, so that's 1 over 1. That's meters on top. The seconds is so the rise unit is meters, the run unit is seconds. So we get 1 meters per second as our velocity. It's a flat line that goes across like that. Now for the next part, let's go ahead and we're going to actually calculate the slope for 2 regions and get 2 separate pieces of the graph. So for up to 2 seconds, we're going to get the slope as 4 minus 2 over 2 minus 0. That's going to give a slope of 2 over 2, which is 1 meter per second right here. Perfect. And then for the last part, we are at 4, 0, coming from 2, 4. So when we actually get the slope for the second part, we're going to get that that is 0 minus 4 over 4 minus 2, which gives us negative 2 as the slope out to 4 seconds, like this. For the third part, for the third graph, we are going to get this in 2 pieces. So we have one part going from 0 to 1 second. We can actually read the slope as 2 there. And when you calculate the slope here, again, this coordinate is 5, 4. This coordinate here is 1, 2. Let's go ahead and actually get that slope for this last part. So that slope is going to end up being 4 minus 2 over 5 minus 1, which is 2 over 4, which is 1/2. So we actually draw half right there. And those are the slope graphs for the first part of the homework. And we'll take a look at the second part. Actually, you know what? We'll finish out to practice 5. So what does the slope of a position graph tell you about the motion of the object? It tells you the velocity. Now, when we look at the velocity graphs and we actually look at the units of the rise are centimeters, the units of the run are seconds. So the units end up being centimeters per second or meters per second. The area under the velocity time graph, we actually did that in class using the buggies. And what we concluded is that it tells us the displacement or how far it went. So it says for each graph, calculate the displacement using the position graph and check your answer. So I will show the answers here, but I'll actually do the calculation on this page. And I will use this color. And I'm just going to say that this is question number 5 right here. And I'll write it here. So for question number 5, here, I'm going to say that the displacement is 4 minus 0, which is 4 from the position graph. Using the area here, I have a width of 4 and a length of 1. So 4 times 1 is 4 meters as well. So we confirm both ways that I get a displacement of 4 meters. For number 2 and number 3, we'll do a similar calculation right here. So I end up at 0, having started from 2 vertically. I read the vertical coordinates. So I'm going to end up getting 0 minus 2, which is negative 2 meters. And let's use area now. So this area here is 2 times 1, which is 2. This area here is negative 2 times 2, which is negative 4. So 2 plus negative 4 also gives me negative 2 meters. Perfect. And then for the last one, let's just see. So I ended up at 4 from 0, so my displacement is 4. Let's see what we get here. I end up getting a displacement of 2 here, whereas I have a height of 1/2, or rather, a length of 1/2 and a width of 4, so that's 4 times 1/2, which is 2, so 2 plus 2 gives me a total area of 4 meters. And that is how I actually do my displacement calculations using both. In the next video, I will actually be finishing up what we wanted to do for the rest of these problems here.